Now that we've got a RISC CPU running really well, let's go ahead and design a game for it. Right after writing Hello World back in the day, you probably would have written a program that lets you guess a number. That sounds like a really good application to start with. It also sort of capitalizes on the craze that there was back in the 70s for extrasensory perception, or ESP. Extrasensory perception, or ESP, is defined in Wikipedia, and it has a concept that came actually from a Duke psychologist, so I find that kind of interesting. But it includes intuition, telepathy, psychometry, clairvoyance, precognition or retrocognition, and also called second sight, a form of extrasensory perception. So I'm not sure the ability to see into the electrons on the machine is much of a test of anything, but it's a fun thing to play with, and I don't think we're messing with any devils to do it. Since this is our first game, I've created a folder called Games, and we'll put the game in there. But let's start from a place where we already have a fairly good sized piece of code, and that's our I/O test. So let's grab that piece of code and copy it over to our Games folder and rename it. Let's see, Games, and let's paste it there for the moment. We'll probably create a folder later, but let's rename it as G001, and we'll call it hex guess and ESP, just because we're going to have some fun with this. This program's got quite a few things inside of it that we don't need, but we'll start there anyway and trim out what we don't need from the other test. We called this G001 hex guess ESP, and we'll say guess a number. We'll just start there because we don't know much about it yet. Number, it doesn't have any of this other stuff. It doesn't need a prompt, but it probably will need a banner, so we'll modify one of the strings and make this thing the name of the program. G001 hex guess ESP, and that's probably a good place to start for the first line. We have a line buffer that captures input and it reserves 80 columns. We don't need that, as much of that for this. We don't need a syntax error. Maybe we'll leave it. We'll leave a number formatting function. Nope, got off screen there. And we'll change the syntax error to bad number. Error. We don't need running. Don't need hit any key. But we want to do things like, let's say, too high. Your guess was too high, and we'll do too low. Your guess was too low. Too low and good. God, how about got it right? That'll be a fun one. And we can say all sorts of things here. Congratulations. You got it right. And for now, we'll get rid of all of these. Oh, no, we'll probably have another one for, maybe we need another one for number of guesses. Sorry about the traffic noise in the background. I live on a busy street, and it's summer. I have the window open. And we'll say number of guesses. And I'll probably want to print a number after that at some point. And that probably is all we need for strings for the moment. Now what are we going to do for main code? Well, clearing the screen's fine. We don't want to print a menu, but we want to print out the banner. So if we say to print, we'll say print banner. So we have a function for that. And then we'll get a line, and then we will, instead of parsing it, we will check. Check result. Check, how about check guess? Okay, so we need to print the banner, we need to get a line, we need to check the guess, and we'll print messages inside of there. So print banner, pretty simple. We'll take care of, remove our print menu, print banner. We save R8 because we're going to be using it when we call the function that prints the screen. We start out by printing a new line, which we don't really need in this case, but what we want to print is the banner, which is hello, guess hello banner. We only need the lower part of it, so that'll load it into R8. And then we can call the function that does printing screen, and that print screen function prints both to the ANSI display and to the serial port, and we'll use the serial port to capture the data. So let's go ahead and add our function here for check guess. And for now, it'll just do a return, which on this machine is a pull PC that executes a return, because when we did the branch to it, the BSR stuffed the program counter onto the stack. So let's see what other things we can get rid of from this code that we don't need. It has quite a bit of extra code. Get line, probably we're going to use. Parse line, well, we're not using parse line exactly, but it has some things in it that are close to what we want to use. Maybe we'll use it, because what actually parse line does is take line buffer that was read in and then convert that to two-digit values. In our hex value, we actually want to have this program guess a number, and the number is going to be a hex number. So it'll teach people a little bit about hex if they don't know it, from 0 through FF. So it's a two-digit number. Does some pretty simple stuff. One of the things we probably want to do here early on is, after we print the banner, we want to get a random number, and that's going to be interesting. Let's talk about that. Random number will return a value in R8. Let me write the function for that. And this is going to take a little bit of thought here, but it really isn't that complicated. For the moment, let's just make that random number 1. So we're going to do a load immediate. Load immediate extended R8 with 0. And after we load immediate rate with R0, we will do a return, which is a pull PC. Got used to doing that now. So that'll give us a random number of 0, just a good place to start. And then let's take that random number and store it into R15, and we're not using that anywhere else in this function, so we can easily do that. So let's do that with an add immediate into R15, and we'll add R8, and we'll add 0. So BSR get line will go off and get a line from either the serial port or the keyboard, the PS2 keyboard, and it'll store into R8. So we want to take that number and then convert that line into the number value, the hex value we got. So the get line went off and stored inside of this line buff string the value of the characters that were typed. And we're only looking for 2 digits, so we probably want to add up in here, actually we really want to add something up in here that tells the person what they're going to do. So guess string dot string guess hex number 0 through 255 decimal or FF. And we'll let them put it on that line when they're guessing the number, so it'll keep repeatedly doing it. So we want to print this string, and to print that string we have to do a BSR to print line, or print string actually is what we really want to do. And we want to print to the ANSI and to the serial. But to get that line to print, we have to do a load intermediate extended of the guess string, and we'll put that right here, and we'll load the lower part of that, and we'll put that in R8 so that it'll actually do the printing. And really we could probably do the same thing here and not have a separate banner function. Let's say LIX R8, and the banner is that value, and we'll get the lower part of that as well. That grabs the bottom 20 bits, which is well beyond our addressing space for the data that we have. You can see I've got the order out a little bit here. I think we want to grab the random number right after we print the banner, and to print the banner we really don't need to call print banner anymore. We need to call print line. Okay, let's take a look at the logic. We're clearing the screen, printing the banner, which is G001 guess hex guess ESP. We're printing that out, and then we're jumping off to the subroutine that gets a random number. We'll fill that in a little bit here, and then we're storing that random number in R15. R15 as random number, not very random, so far it's only 0. And then we're printing out that guess string, guess a number from 0 through FF, and printing that out to both the serial and the screen. And then we're calling getLine, and then we have a routine that will convert that line into the hex digit. And let's go ahead and take a look at that function. We previously called this function hex to 7 seg. Now it's not in this case being used for the 7 segment display, but it originally was. What that does is grab the address of the line buffer, which was passed in R8, puts that in the data address register, and then goes through and grabs each of the characters at a time, and will then dump that out to the 7 segment display, which is fine. We don't really care about that, but it will return it back in R8. So that's actually very much the function that we want. So let's go ahead and grab that. It'll also give us the advantage, if we have a 7 segment display attached, of being able to see it, see if it works. So our check guess then would go and compare R8 to R15, and if they're equal, then it would say you're done. If it doesn't, then it does something else. So let's get rid of the check guess and just do this up here inside of the main function. We really don't need it, and it avoids having to pass R15 down to the lower function. So we don't need that check guess anymore. But what we want to do is compare. Let's make a note here of what we want to do so we don't lose track of it. Compare R8 and R15. If R8 is R15, then you are done. We can check our basic logic here pretty quickly, but let's go ahead and implement that. Probably got to use a semicolon there. Okay, and we'll do compare R8 and R15, and if they're equal, we'll go to guessed it, and we'll throw that down here. So that what we do down here is something very similar. We load the "You Got It Right," which we're going to get from here. Your guess, congratulations, and you got it right. And we want to print that out as a line to the screen. You got it right, and print that out to the screen. And then let's just do stop at that point, just for a place to stop it, because we can do a quick test of this particular application so far and see what we've messed up. Probably a few things, we usually do. Alright, so let's go ahead and save that, and then we will run the assembler. It's a command prompt based assembler, and let's go find it. It's located in the tree under assembler, and we can grab that, but we really want to be in the program space anyway, so we'll go back to the programs and we'll go to the games, and this is where we want to be at to compile this program. So let's change directory to that folder, and now we can compile it. It's a couple paths back. Maybe it's another path farther back than that. Let's see, it should be back. Did I go back too many levels? Yep. And it will be the G01 program. And when we compile it, it tells us we have an error here at line 192. Don't even think I changed anything down at line 192, but let's take a look. It's all of those other strings that we have. So let's trim out the extra stuff here. We're not testing ring LEDs. We're not testing the 7-segment display. Not testing push buttons. We can leave the read switches function in case we want to use it later on. We're not testing dip switches. And we might want to send out an ANSI sequence later on. We don't need the screen test itself though, so we can get rid of that. There's quite a bit of code in here that can go. Don't need the serial port test. We don't need the I2C. Delay from jumpers we don't need. We'll leave the print long because we might want to print the number. We certainly will, probably along the way somewhere. And we have the ability to print a hex value. That's probably what we really are going to want to keep. Let's get rid of the I2C stuff here. Quite a bit of that in here. Quite a bit of that in here. Get rid of the SPI test. We don't need that. Keyboard. PS2 keyboard test. We don't need it. We already have functions for using it. Don't need the buzzer test. We don't need the timer test. We can take that out. Timer tests are done. Don't need the rings. We do want to have the hex to 7-segment function. We do want to have the ASCII to hex. We want to wait on characters from UART. We want to put a character to the UART. We want to print strings, print lines, new line. Yep, we want to have all that stuff. This particular card doesn't have a buzzer, but let's leave that code in. We probably are going to want delays, possibly. We can leave that in, get the character from the PS2. Yep, all that stuff. Wait for character. Yep, I think we'll leave all that in place. And let's go ahead and try to compile again. That probably should get rid of the error that we had, at least get rid of the one. Okay, it's line 112. We still have the menu code in here. So let's go back up and trim out that menu code because we don't really need any of it. We don't need the parse line function at all, which is going through the menu in the I/O test. Just get rid of all of that. That should cut things way down. We'll leave read switches in here in case we want it for later on. Get line should still be there. That should work for that. Now let's see what other fragments of the other code we have left. Fantastic, nothing left. Now I'll take a quick look at the listing file that it produced. That's one of the beauties of this assembler, is it does make a listing file. You can see here on the left is the classic address style. We don't go up by 2 or 4 for addresses, we go up by a single count because we don't need, with everything being 32 bits only, we don't need to have those lower 2 bits that would normally be there, and we can just have a larger space. So we have D4, BSR, and all the functions, and yeah, it looks basically right. All right. So we've got it to compile, and we produced the hex files we need. So let's go ahead over here, and inside of Quartus, we'll reassign those files to the game files, the hex and the other one. The instruction ROM is here, and if you double click on it, it'll bring up the wizard. And now we just have to go and point to that new instruction code. And that should be in the tree, not too far from where we're at. It will be under Programs, and then it'll be under Games. And we're looking for the INS, which is the instruction space. We finished that up. And the RAM is actually wrapped with a wrapper around it. So we have to click the one below that to change the RAM file. And the RAM file is those strings that we were looking at. So this one's a little bit different. They moved the next on that, which is a little bit annoying. But let's go ahead and point to that file. And the Games folder under Programs. And we're looking for the DAT. So we'll hit Finish twice. All right, let's tell it to go ahead and compile. Compile time was 1 minute and 39 seconds on my quad core 3.6 gigahertz machine. Not state of the art, it's an older HP that I got on the used market. But let's go ahead and upload that to the card and see what we get for a result. That's disappointing. We got absolutely nothing. Well, let's see if we can figure out where we went wrong. Well, when I say we got nothing, it's not exactly correct. We do have the light on the LCD screen, which tells us we have H-Sync and V-Sync, so probably hooked up okay on the VGA cable. We don't have any text on the screen, but we do have, I do think I see the blinking cursor up there, so the ANSI terminal and all of that came up perfectly fine, but it looks like we're waiting on something. I wonder what that is. Go back in the code and see if we can see something obvious here. Okay, what are we doing? We are calling the clear screen, which may or may not be working. It's hard to tell. We're loading R8 with the banner, which is the guess. That should have popped up, and we're calling off to print line. Let's see what print line looks like. So print line tries to print to both the display and to the UART. I'm wondering if the UART port is not is hung at the moment. What if we just try going directly to the ANSI display? Will the banner come up? Let's give that a shot. I think that's how I do that. Maybe it's not. But string ANSI is actually what I want for that. And let's see if that calls it up. Go ahead and compile again. Or assemble. It assembled it. And sometimes we have success doing process, update memory initialization files. It'll grab that new set of files and then hit compile. If it goes well, you can see it pop to 40% immediately here, and you'll see how quickly it will compile. Looks like it's about 7 seconds for the second pass. So the first pass is longer because it doesn't really have those files understood where they are, and it was the first time I've run the assembler or the FPGA fitter and all of that before Quartus. Now let's go ahead and start that and see if it works. And no banner. Wow, wonder what really went wrong here somewhere. I think I know what it is. There's no timeout currently on waiting on the keyboard or on the serial port, and it's trying to pull both of them to see which one has a character on it. And I ran into this yesterday, the exact same problem, and the problem was that if you're not running PuTTY, the hardware handshake isn't turned on, and this particular card requires hardware handshake to work. The other cards don't really. As soon as I hit it, I got a screen full of stuff, and up here I see on our screen, guess a hex number. Let me make that bigger so we can all see it. We'll go for a lot bigger characters. Make it big enough to see. All right, it's coming up saying guess a hex number. I see quite a few things on the other screen, not quite sure what they are. I'll have to try to figure that out, but if I hit the reset on the card, it should come up and ask for a number again, and it is doing that. So both of them are doing the same thing, only it's asking for a number. So let's put in 00 and see what happens. It's coming back and saying bad number error, bad number error. So there's some syntax parsing here. Let's go figure out what's going on with it. I guess the lesson to learn here is with this particular retro card, having the hardware handshake is a blessing and a curse. It's a blessing because you can run at a lot higher baud rate, and it gets, if the CPU can't keep up, the hardware handshake line gets yanked to the USB, which is much faster than anything else, and tells the host computer to slow down. But if you don't have it run through PuTTY, then that line is in the wrong state, so it doesn't, it hangs on waiting for the keyboard because nothing will be there. It just says that it's not ready. We could add a timeout for that. I think we have another program function that does that. Time it out and say, hey, just disallow it at this point. But we're taking baby steps here. One thing to note here is that our banner never got printed, but on the screen we see the line buff looks like it got printed. So there's something going on there. I think I must be calling the wrong function. Let's go see. Well, I think the answer here is the print line, because I think that's going to print out what's in the line buffer. So I think we want to go back to the other print function, and that should print out the right banner. Let's go check it out and see if it works. All right, we need to recompile or reassemble. Assembled fine. Go back into the FPGA program. Processing, update memory initialization file. Hopefully this will go quick. Sometimes it does and sometimes it doesn't. Most of the time it gets in a good mode of going quickly, and if we see it hop again to 40%, we know we're there. So this should work just fine. And when that's done, we will do the download or upload. I'll hit the start button on the programmer, and guess what? It comes up G001 hex ESP, guess a number from that to that. Now let's see if we see that over here on PuTTY. Yeah, it does. Oh, looks like we wanted to print a carriage return line feed in here and we missed that. So let's throw that in. The iterative process is so quick here that we might as well just go ahead and toss it in. Right after we do that, we'll jump off to, I think it's called new line. New line ANSI and UART. Okay, so that should fix that problem. Let's go see. Maybe we want to print two of those while we're here, just because it's a nice thing to do. And we need to assemble again. And there we go. And we need to upload again, or compile the FPGA and then upload it again. Update memory initialization, yes. And that updating the memory initialization file only takes a few seconds. And if we click this, and again it says 40%, we know we're going to be on a quick track to make this work. Might as well load up the programmer because this is so quick. Hit start, upload it, and by gosh, it looks great. Well, at least on the other screen it looks great. Now the weird thing here is that the terminal gets left at the column it was. It's one of the strange things. You would think the reset would do that, but it doesn't actually fit that. I think that's something about the ANSI terminal. So let's go ahead and solve that just by throwing another new line before we print the banner. Then it'll be good anytime we run it. And again, since the iterative process is so quick here, we might as well just go ahead and do that. Got to assemble it again. There might be a way to build all this into one easy tool chain. I don't quite know what it would be, but it's a few clicks around the screen. And if you lay the screen out better than I'm doing, just for the sake of this video, it'd probably be fairly easy. We'll go ahead and do that, and we'll get ready to program because it's going to be quick. This is tons quicker than an Arduino environment is for compiling and downloading. I mean, it's already downloaded. Screen looks good on the VGA. I'll have to take my word for it, but it looks good here too on the local side. So we've got the banner message up for G001 hex guess ESP. Wow. And it's asking for a hex number, and if we put in 12, it comes back and says bad number, error, and a bunch of other stuff. So let's go try to figure out what's going on with that. So it'll take us back to the code, and let's follow our logic. So I think we're good up to here. Random number. Oh, it loaded R0. That's not a good thing. It should have loaded R8 immediate with 0. That might work a little bit differently. Loading R0 won't really do anything, but let's see if that changes anything. Probably doesn't, but it's definitely an error in the code that we have there. So might as well fix that and have to assemble first. Assembled, and have to load the memory initialization file, and tell it to go immediately to 40%. Oh, this is going so well. Like I said, sometimes it doesn't do the same process of quickly compiling, and I have the flag set all the time, so I'm not sure exactly what's going on. It came up on the screen just fine. We can see it here just fine. If I hit 00, it comes back with bad number, and the other screen is showing the same print error. Not showing it here because I'm printing a little bit differently here, but let's see what's going on. So it should say, I'm sure somebody's watching this saying, boy, you're dumb, you're missing it, buddy. Random number was 0. Took that 0 from the random number and copied it back here. And if it was equal, it guessed it. Otherwise, it goes off to print line. Well, I don't want that print line. I know already that's the wrong thing, so that's what's going wrong there. If guessed it, oh, we need a piece of code here that branches back to not right, we'll call it. And let's throw that code in. And we wanted to get the basic screen stuff up, and we got it up. And we want to come back up probably close to here, I think, where we print out the guess string, get the line, do the conversion, compare it to R15, and go off and run. Let's see what that does. That probably gets us something that's a lot closer. All right, we're assembled. Update the memory initialization file. Compile the FPGA. Never wondered if compile is really the right word. Seems to be a common word for FPGA stuff. Start. And let's see what we have now. So we didn't hurt anything. If we guess 00, comes back and says bad number, bad number. So there's something wrong with that, but we did clear all the other stuff off the screen, the VGA screen, because we're using the right print function now, not printing out what's in line buff. Let's go see what bad number error is. It's the thing that used to be the syntax error. So if we go look for that, we'll find out what's going on. This is where it gets printed. So it's taking R8 It's looking at R8. So what gets passed? Single ASCII character gets passed here, but what are we passing to ASCII to hex? That's the question. Let's go back to where we were and take a look. ASCII to hex. ASCII to hex. Well, that's hex to 7 segment. That's a different one. Let me go back to here. Hex to 7 segment is calling ASCII to hex. It is R8 points to the start of the hex string. So what do we have to pass it? We probably have to pass a line buffer. That might be our problem here. So when we're reading in the line, it's going in a line buffer, but we're not passing it to that. So we need to do low immediate extended R8 with line buffer lower. Let's see if that makes a difference. That might give us a better result, I hope. Assemble. Update memory initialization. And compile and get ready to upload because it's going to be pretty quick. Again. Go ahead and start. And it came up with the thing we would expect. And if we hit 0, 0, it says, congratulations, you got it right. That's really good. Let's hit the button again. Let's say 03. Oh, not a good answer. Well, we're not printing anything that's not a good answer, but 0, 0 is what our random number was set to. And yeah, we did get it right. So let's go back into here and take a look. Bad number error, your guess was too high, your guess was too low. Let's just add for another, for the moment, and not right. Guess. String. Wrong guess. Your ESP powers must be weak. All right, not right. So let's go back down to here. And not right. Well, we haven't guessed it, so let's put it here. Load immediate extended. R8 with that. And then we want to call that thing to print out to both places. And now we should have a not right message. Let's go see if that worked. Oh, got a typo there. Load immediate extended R8 with not right. It's saying not right is not a valid immediate value or a local label reference. Well, it's actually true because it should say lower. That will grab the bottom bits of it because you can't do a 32-bit load on a 32-bit instruction and have anything left over for the opcode. Oh, let's go ahead and try it again. Hopefully that showed a good assembler error. Not right. Wow. Oh, did the wrong thing. Definitely did the wrong thing. And we actually can have a data label and an instruction label the same, but let's just separate them here just for fun because now we have two things to both say non-right. That's definitely going to be confusing. So that should be not right lower. Should grab it into R8. That'll call print string, and in theory, this will fly. Hopefully, did assemble okay. I keep wanting to say compile. Go ahead and upload the memory initialization. Put that compiling, I guess. Go ahead and hit start and let's see what we have. So it's asking for a number. Again, if we guess 00, it should just still work, which it does. Let me reset the card. Let's guess 03. Oh, wrong guess. Guess a number. 04. Oh, wrong guess. Well, we want to put a new line after the wrong guess. And I think there's a version of it that does that, but I think we can just do the same way we did it up here. Let's see, guessed it, pen stop. Guessed it, not right. And before Return, we'll print the new line, and let's go try this one out. I think we're pretty close. Coming up on how we're going to do the random number, that's going to be the fun part. I have a thought for that that's maybe obvious to some people, I don't really know. Random number generation is a very challenging subject, but we have something on the card I think that can help with that. And what we also have is a human user, so I think we can make a pretty good random number generator. We'll see how well it works. It should be pretty good. If I hit start, I think we're there. And let's see where we're at. So it wants us to guess a number. We know it's 00, but we're going to guess 10 hex. Wrong guess. How about if we guess 3F? Ah. Oh, wrong guess. How about if we guess GG? There's no such letter. Ooh, tells us that was a bad number and wrong guess. Good. Looks like we've got the basic program logic up right now. I think we'll stop this video at this point because it's probably running long, and add random number generator and maybe some other things in the next video, and high-low indication if we want that as well. So anyhow, thanks for sticking it out on this long video. Appreciate it. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.